In this video lecture, we're going to talk about the fundamentals of building graphical user interfaces in Java. Talk about some of the foundation classes that are required to build GUIs, and what we're going to do is take a look at how to structure our program so that we can build GUI applications. One of the things that I would like to mention in this lecture is that the way I'm going to show you to build GUI applications is a way that works really well for building simplified applications for a class such as this. If you were going to scale and build large GUI applications, such as you want to build like your own word processor or your own integrated development environment or something along those lines, the approach that we're taking here probably won't scale that well, but it does work really well for things like a small Twitter application or a calculator. Basically any type of application that has a minimum number of screens to display and where the underlying business logic is not too difficult. For those of you that are considering building larger GUI applications in the future, I'd recommend you take a look at the model view controller pattern, and also I would recommend that you get a book because and just do it, because that's a very cool undertaking. All right, so let's talk a little bit about what makes a GUI application a GUI in Java. And yeah, I will say the word GUI, G-U-I, many times in this lecture, so be prepared for it. All right, first thing we're going to look at in this set of code we've got here are the two import statements. There are two packages in Java that provide the bulk of the graphical user interface functionality that we'll need. The best way to explain this is that java.auth, which is the abstract windowing toolkit, we can best say is the older way of building GUI applications, and it is more tightly tied to the underlying operating system than javax.swing. Swing is more abstracted from the underlying operating system, and Swing is the more, let's say, modern way of building GUI applications, because it gives us the ability to put high-level GUI widgets into our program. And a widget, what's a widget? A widget is a thing like a button or a radio button or a slider or a text input. I just use the generic term widget to describe any of these elements that we would put into a graphical program. So the other thing auth also provides is some low-level drawing code that Swing does not. And so for almost every program, it's just easy to import both of those namespaces so that we have all of that functionality available, and there's really not a confusion there. One thing to also notice with importing javax.swing, it's not just java.swing, it's javax. And this is kind of a leftover from the early days of Swing, where it was in a package called Java extensions. And so many people took to using Swing that I guess they really couldn't get rid of that X. So it's one of those things that causes errors when you start writing code with Swing, because a lot of people just aren't used to seeing the X. So it sounds like Klingon, you say javax, and just don't forget it when you're importing Swing. I usually just copy and paste these lines because it's easier. So next thing we're going to do is set up a standard class like we've had in the past, and I'm going to jump right in and just write this code into my main method. Why am I not getting into any type of high-level object kind of organization, or maybe looking at some UML? For right now, we just want to focus our goal on just learning the fundamentals of building solid graphical user interfaces. Okay, so a couple of things you need to know. Every application is going to have what's called a frame. A frame is basically the container for your window. So I'm going to go ahead and run this application, and you'll see what I've actually got coded up here. And what you'll notice is I have got this little application. And yes, I'm using a Mac, so the window bars are Macintosh based, but if you were to run this on a Windows machine, everything would look like a Windows machine. So what's the frame? Well, the frame encompasses, the close, minimize, and maximize buttons. The frame encapsulates the title of the program. You'll notice that in the title bar of my window frame here, I have the word samples. You'll notice on line 9 of my example program, I have the string samples. So there's a direct correlation between the string you pass into the JFrame constructor as to what appears in the title bar of your application. Now, what else composes the frame? Well, think of it like a picture frame, right? You'll notice that this entire edge that's kind of containing the yellow, in other words, it's framing the yellow of the background of my app, that's the frame. And the way I tend to teach writing graphical user interface applications in Java is that I ask that students never directly add any type of components to the frame. I ask that you use a panel-based approach. And it's just something that I've found works really well for everyone. Oh, by the way, what's in this window? It's Tux, everyone's favorite Linux penguin. Notice, by the way, that I can expand and resize this window. I've done nothing, by the way, and as we look at the code, that functionality is provided to you for free by the frame class, or the JFrame class in this instance. So what's really cool is this looks like a window, it works like a window, and it's very similar to how you might expect window to operate in any application, and that's what's really nice is this is very standardized. So actually, let's keep Tux in the window, and we'll come back to him in a second. So a couple things. I'm instantiating an object of type JFrame, storing it into a variable called frame, calling the constructor, and I'm passing in the title that I want to appear in my frame's title. And basically, the next thing I'm doing is I'm asking the frame object, I'm calling the method setDefaultClose operation, and what this does is it tells the application what I want it to do when the close button is pressed. And you would think, well, sure, you want like your application to close when you click the close button, but sometimes you might want a service to run in the background. Think of if you use like a game client like Steam, when you close that window, it kind of puts itself in the background, and you can always just Alt-Tab back to it. So sometimes we want to close windows without actually closing an application. That's a pretty standard thing. So we could actually change that functionality here. If you're curious how to do that, obviously at this point I hope you're used to looking at the Java API, and you can just jump to the JFrame definition and look for that defined constant that would give you the additional functionality. So I said that we're going to use this concept of not adding GUI components directly to the frame. Well, think about it when you have a picture in an art museum, right? There's a canvas, and then there's painting on that canvas, and then that canvas is put into a frame. That's the same approach we want to take. So what we're going to do is we're going to add everything to what's called a panel, and then we're going to add the panel to our frame. So we can think of a JPanel as being the canvas on which we're going to build our graphical user interface. So I'm going to go ahead and I'm going to call my panel primary. And notice, by the way, these all start with the letter J. That's an indication that these are swing components. So I'm going to add to my JPanel. First thing I'm going to do is I'm going to create a JPanel, assign it to my primary variable. I'm going to call a few variables on my JPanel. And one of the things you'll notice is that I'm immediately setting the background color to yellow, and I'm setting the dimensions. And if we look at this yellow area, you can see that that is the JPanel. Why? Because I set it to yellow. And you can tell when I launch this application, right, we only saw the tip of Tux's head. Why? Because I set the dimensions, or the preferred size of that panel, to be 300 by 100. Okay? But I can still expand it and see what's there. So this idea is I have a panel, and that panel is contained inside my frame. The book demonstrates that you can add components directly to a frame, but I like to see my students kind of skip that step and go right into using panels as your main container, because as we build more complex programs, what we're going to do is we'll have multiple panels, and we can add panels to panels, but in the end we only need to have one frame. And that makes sense that if, I'm sure a bunch of you have collages of photographs maybe hanging in a room, or of, pictures that are, on your wall that have multiple pictures, but there's still only one frame. So it's nice to kind of keep that one-to-one relationship between the metaphor we're using here. Okay. Now the other thing here is you see that I've got the word hello class, and I've got Big Tux Penguin in here. So let's go back and see how these are added. So we've learned already about JFrames, we've learned about JPanels. JLabels are nothing more than components that allow us to display strings. They can actually be clicked on, but they can't be edited. So JLabels are pretty good for just displaying bits of information. And I forget if you can see it, but at the bottom of the JGrasp window, there are these things like status, running user program, line 18, column 46. These are uneditable displays of information. And what's really nice is that these are represented via labels. They are non-editable text components. So if we jump back to Tux, hello class, I'm clicking on it, but I can't edit it at all. It's just displaying a string. I've named that JLabel greeting, by the way. Notice I'm using variables that have names that are consistent with the type of components that I'm putting together. The next thing is I want to display an image icon, and anytime I want to display an image, the easiest way to do it in Java is to create an image icon. Yeah, I'm using a GIF. This example's existed for a pretty long time, so I haven't really upgraded to PNGs. But the idea here is you can see that if you look at the image icon class, it accepts a number of image file formats. Notice, by the way, that the path of this file, my tux.gif file, is in the exact same directory as my current class file. That's why there's no path here. Otherwise, if you wanted to put that somewhere else, you'd have to put a valid path in there that would find that file. So I'm going to create a new image icon. I store that into the variable icon. One of the nice things about displaying image icons within GUI programs is that you can actually add images to JLabels. So what I've done is I've gone ahead and I've created an image icon. I've now created a new JLabel and I've passed in my image icon to that JLabel and I've called it tux. This idea in Swing is extremely important. The idea that you have components and you can add one component to another component. I just added an image icon component into a JLabel component, right? And now I'm going to add that JLabel component to my JPanel component. And then eventually I'm going to add that JPanel component to my JFrame component. And I'm saying component, but the reality here is we can think of GUI components as both being components, and some components are also containers. So we would say that my JFrame contains my JPanel, my JPanel contains JLabels, and my one JLabel actually contains an image icon. And so this idea of GUI components being embedded in other GUI components and being able to contain other GUI components is really important. Scrolling on down, we want to go ahead and add these widgets to my panel. It's really important to realize that once you've created your GUI components, you need to add them to a panel. If you don't add them to a panel, they won't appear. So notice that I'm adding them to primary. Well, what's primary? Primary is my JPanel. What's my JPanel? It's the canvas on which I'm painting. And notice that the order in which I add them to the panel affects how they're displayed. The reason why Hello Class appears top and Tux appears below is that I added greeting first, then I added Tux. Finally, I need to go ahead and I need to add my panel to my frame. Right? I've got my canvas. I now need to frame my canvas. And what I do is I ask my frame for its content pane, which is really the area that displays the bulk of the information. Right? It's really the space inside of the frame. I call an add method and I add my JPanel. I then perform what's called a pack, which helps with getting everything organized in terms of the GUI that I want to display, just to kind of simplify it. For more detail, you can look at the API. And then I set the visibility of my frame to true. What's kind of interesting here is you can hide frames. Like you can have a frame disappear, or you can have a frame reappear. You can have multiple frames in an application, right? Remember that a frame is just the border of a window, essentially. And in Windows or Mac OS or Linux or whatever, we're used to having multiple windows. So usually what happens here is these last three lines, if you take the approach that I use to write graphical user interfaces, are like a copy and paste. And if you continue to use my naming methodologies of primary for the main JPanel, or if you want to call it main canvas or something, you can literally go ahead and just like copy and paste these first two components and then these last three lines of code and end up with some code. One other thing to notice before we stop on this specific topic is that if I expand this window sideways, notice how the GUI components inside of my window reflow. Well, by default, when you just kind of throw things into a JPanel, you end up with what's called the flow layout manager. Well, what's a layout manager? A layout manager is a special object that allows you to dictate how components appear or are positioned within other components. And in this case, since we have not declared a layout manager, what I end up getting is the flow layout manager. So as I expand and shrink this window, the components within the window will kind of just wrap around and find their most natural position, which by the way would be left to right, top to bottom, just like reading in English. So the idea here is that by default, I don't have a lot of control over how these specific components at the moment are positioned within this window. If I want to have a lot of control about how these components are positioned within the window, then I would have to implement what's called a layout manager. And in this lecture, I'm not going to discuss layout managers. Save that for another time. But for now, please note that some people who are very obsessed with how things are laid out may be getting rather annoyed at how things are currently laid out using the Flow Layout Manager because they don't stay in the same spot. In this section of the lecture, I want to take a little bit of time to explore this concept of nesting panels inside other panels so that we avoid putting GUI components directly into the J-frame. And this is also a good lesson in looking at nesting any GUI component into any other GUI component that can act as a container. And you can see how my code is organized. And again, this is a good approach for the types of apps that we're writing in class. So, looking at the example in hand, I've imported my auth and swing classes, or swing packages, so we have those both available to us. And I'm doing all my work in my main method. The next program we look at, we'll start to break out of this main method and start to organize things more into classes. But for now, let's just look at this functionality. I create myself a JFrame. The label on it is going to be my cool application. And again, when you click on the close button, you are going to exit the application. Let's run this and see what we get. This creates this really little window. And what you're going to notice is if I expand this, I have this gray area, I have a red area with some things in it, and I have a yellow area with a label in it. Basically, this gray area is one panel, this red area is another panel, and this yellow area is yet another panel. And what I have here is I have two panels, a red panel and a yellow panel, that are added to or embedded inside of the larger gray panel. And that larger gray panel has been added to the J-frame. And why am I doing this? Well, the idea here again is that if you break your program out into different panels, it gets to be a little bit easier to organize. It also gets a little bit easier to lay out. And again, you can, if you have multiple panels, it also becomes easier to use multiple layout managers to organize your program. So let's look at how this is organized. And we can actually keep this little application in view as we walk through some of this code. So first thing I do is I create a new JPanel. I call it M for main. I set its background to gray, and that's where this gray background comes from. I set up a new panel called L. This is going to be my left panel. I set its background to red. And then I'm going to create another JPanel called R for right, and it's going to be set to background color yellow so that we can see it on the right. Now what I'm going to do is go ahead and I've created my main panels, and I'm going to go ahead and I'm going to create those GUI components that I'd like to add to those panels. So what I've done is I have added a label called left, and I set its value to left panel, and you can see it here. And I've set this label to right panel, so you can see that here. So that's where that text is coming from. I've created two J labels for that. And then I'm introducing a new component here called a text field. And I am going to go ahead and add that value here. So that way the J text field is being added into the component, and that way we'll have a few things to put into that left panel. Notice, by the way, that when I create a J text field, the text that I display in the constructor is the text that's displayed inside of that field, and I can actually delete it, and I could type text in there. Now what I'm going to do is I'm going to add the appropriate GUI components to the various panels that I want them in. So the first thing I do is I go to my left panel and I add both my JLabel that has the string left panel associated with it, and I add my JText field that has the enter text added to it. Then I go ahead and I add to the right panel my right JLabel. Now what I want to do is I need to add my subpanels to my main panel. So I go ahead and I add my left JPanel to my main panel, and I add my right JPanel to my main panel. And the reason why I do it in this order is because I want the left panel to appear first and the right panel to appear second. So this is the process, right? Create your frame, create your panel. Let's make a little more space here. Create all of your panels that you plan to use in your program. Then create all of your widgets that you're going to put into those panels. Add the widgets to the appropriate panels. Finally, add the panels to your main panel, your main canvas, and then finally add that main panel to your frame. And when that's executed and run, what you end up with is something that looks like this. And this process, again, is just an easy way to think about breaking your GUI down. A lot of times students try to put everything into one panel. It gets to be difficult to get the layout they want, and especially, again, in the type of small programs that we're writing, this approach is kind of a nice approach. And one of the things that you can actually do with panels, and I'll let you look this up in the JPanel API, is that you can actually hide and display panels. So you can set the visibility of panels to be hidden as well, which is kind of a nice feature. And I don't have a sample of that, but you can play around with when we look into working with buttons and action events. What you'll notice is that you could have buttons that display certain panels, that hide certain panels. And it's just a nice, easy way if you have a static window that's going to have a bunch of stuff in it. Again, like a calculator or a really simple application like our Twitter app, to organize your data. So making your graphical program look nice is just one aspect of writing a good GUI program. What we need to do is build in interaction to our program so it operates in a way that we want it to operate. I mean, we're going to be interacting with these programs via the keyboard and the mouse, and we need to look at how we can start to do that. So on the right here, I've got a running application. It's got the Firefox or the Mozilla dinosaur here and some strings. And notice that when I mouse over hello class, it says you hovered over me. So notice now that I have a JLabel, and I have that JLabel programmed so that it interacts with the mouse. In other words, the mouse hovers over that label, the text changes. As soon as it goes away, it changes back. And you can see that also now I have another one. I have a label here set to how are you today, but if I click on donate to the Mozilla project, it changes to Woot. And by the way, notice that I can't change it back because I didn't program in anything to change it back. So what I've got here is some interactions. In other words, the program itself is listening to the mouse and reacting when certain events occur. And in this case, I'm interacting with JLabels, which is a little bit odd to do, but I wanted to kind of make a point about, basically this idea of your GUI looking at specific events and reacting in an appropriate way to those events. And in this case, it is appropriate for a label, maybe, possibly, sometimes, to interact with the mouse. So let's see how this is coded. So this layout of this program is going to be a little bit different than ones we've seen before, and I'll kind of call that out as we go. But first thing you're going to notice is I have a constructor, and you'll see that this is actually a class with a main method in it that's meant to drive the class that we're writing. So we're actually going to kind of encapsulate some of this idea of my GUI program into a class. Now, one thing that's a little bit different, I've got my java.auth and my javax.swing packages imported, but now I'm importing the java.auth.event package, and the event packages is what's going to give me the ability to implement interfaces and abstract classes that allow me to write code that lets me interact with components in my GUI using the mouse, keyboard, or whatever input devices are available. I'm recording this and I'm using an Apple Magic Trackpad, so it works just like a mouse. So sure, I'm sure we could get into multi-touch in Java as well, but I've never explored that. And now I'm getting off on a tangent, so let's get back to this program. We're bringing in java.auth.event so we can process events in ways that we want. So let's look at this program. First thing I've done is I've set up 3 variables, 2 JLabels and a JPanel, and I've declared them at the class level. The reason why I've declared them at the class level is I'm going to be writing multiple methods, and in fact I'm going to actually be writing another class inside of this class, and they need to have access to this. So by declaring these variables as instance variables for the GUI sample 1.class, it gives basically global access within inside this class to these variables. Now I'm going to go ahead and write a constructor. And my constructor's job is going to be to set up my panel. Just like we've been doing previously in a main method, we're now going to do this in a constructor. So I set up my frame, I set up what I want this thing to do when I close it. I go ahead, I set up my main panel, set it to gray, so you can see over here this gray area is my main panel. I set the preferred dimensions, and I set it to be focusable, which really is just a way to make sure that it comes forward and that it can be interacted with. And again, you can look at the API to find that out. But when you say something has focus, whether it be a text box or a window, it basically brings it to the forefront and allows it to be interacted with. And it's just a way to make sure that I'm getting that ability to interact with the application. Now, a couple other things I'm going to add are my labels. So I've got a top label and a bottom label. Hello class, how are you today? And I've also set up an image icon which contains this little picture. And you'll notice that I've also gone ahead and created a new JLabel. And I'm using a different constructor for JLabel. Normally we're looking at the constructor for JLabel that only accepts a string. Well, in this case, there's an overloaded constructor for JLabel that accepts not only a string, but it also accepts an image. And then it also accepts information about how that image and that text should be aligned on the horizontal line on which they appear. So I'm actually creating a JLabel, and that JLabel actually contains an image and some string text. So what's really nice here is they are really one component. So as I expand this, notice they stay together, right? They're not two separate components. Why did I choose to do that? I just chose to do that to demonstrate that that's possible. And the more you dig through the API, the more cool stuff you can find. Now, you're going to see something here that's new. I've got a JLabel called top in terms of the reference that refers to it, and bottom that points to this other JLabel object. And I'm going to call this method called addMouseListener. And you'll notice as you go through the APIs for various components in Swing, you'll notice that there are methods that allow you to add what are called mouse listeners, keyboard listeners, action listeners to those specific objects. It's this line. I'll turn on line numbering here. On lines 29 and 30, these are the lines that are tying what I'm going to basically say is tying the mouse events to this specific label. In other words, without these two lines, I cannot interact with my JLabels. So I'm calling this method to register with this object that it should be paying attention to mouse events. Well, what's going to happen when those mouse events occur? Well, basically what's going to happen is that object is going to ask this other object called myMouseListener what it should do. And notice that the top label will be asking the object myMouseListener, and the pick JLabel will be asking the object myMouseListener too. These are really delegate objects. In other words, these are objects that will be delegated the responsibility of responding to requests for mouse events for these objects. So it's basically just saying, hey, look, anytime a mouse event happens to this JLabel, ask this instance of the object, myMouseListener, what it should do. So we'll look at how to make those in a second. So that's where we're getting the magic mouse interactions. Once I'm done, I add everything to my main panel, and I just go ahead and I add my main panel to my frame, I pack it, set it to visible, and I get my application. You'll notice the way I've written this program, one of the things that's unique is that my main method simply does one thing. It creates a new instance of GUI sample1. And does nothing else beyond that. It just needs to create the instance of the class, and by creating the instance of the class, it invokes the constructor, and by invoking the constructor, it displays my GUI. So again, this is a little bit different. So again, let's just run this. I believe we're still running, but let's end it and rerun it. We've got this window, and we know now that I can interact with these JLabels because I called the addMouseListener method, and I specifically called that addMouseListener method on the instance of JLabel referenced by top. And in creating that addMouseListener, or calling that addMouseListener method, I passed in an instance. And by the way, notice I'm passing in an anonymous instance of the myMouseListener object. I don't maintain a reference to this object because it's tightly coupled to this JLabel. In other words, there's no need for me to reuse the events that are related to this myMouseListener object, because in my program, the only item on my GUI that's going to be being modified is this JLabel. And so this object, myMouseListener, only knows how to interact with that one specific label. And this is pretty normal. In a Java Swing application, you will have instances of objects that are tightly coupled to the GUI component that they're controlling. There are ways to do reusability, but for the most part, this is kind of the controller portion of our code. This is, what glues our GUI to our business data or our business logic, and it's really tough to make these event classes reusable. Again, there are some strategies for doing that. But anyway, the reason why this works is because I registered this object with this label. And the reason why that magic works is because I registered this object with that JLabel. So let's go down and see how I did it. First thing I did was something I don't know if we've seen yet in the class, is I've declared a new class. And notice something unique here. I've defined this as a private class. In other words, if you scroll back up, you'll notice that this whole class is indented, which is a little bit weird because usually we only indent, methods and, and then components inside of statement blocks. But really, what I'm actually doing here is I'm actually defining a class inside of another class. So inside of this public GUI sample1 class, I have defined another class called myMouseListener, and I've defined it to be private. Well, if this class is private, it means the only accessibility to this class is within my GUI sample1.java file. Why would I ever want to create a private class? Well, I could have actually broken this out and made a public class and put it into another Java file, but the reality is, again, like I said before, this myMouseListener class is tightly coupled to the JLabel in which I'm going to be interacting with. In other words, the only reason this object exists is to interact with this JLabel. So why do I want to go through the trouble of creating a class in its own file that's public and accessible by everybody? What I'm basically doing here is just creating a private class inside of my public class because there's a tight relationship between this object that will be created from this class and the JLabel in which it will interact. Notice that this class implements the MouseListener interface, and the MouseListener interface defines a number of methods. 1, 2, 3, 4, 5. So think about the different ways you can interact with a mouse. You can click it. You can move the mouse over something, move the mouse away from something. Notice that when you click a mouse, too, there's more than one event. Mouse clicked is actually a multiple event process, right? There's the down state of a mouse, right? And then there's the up state of the mouse. So if you wanted to do something on the down state of the mouse, you do mouse pressed. If you want to do something on the up state of the mouse, you do mouse released. Mouse clicked has to do with the whole process of down and up in one method. And notice in this case, by the way, I have several methods that have no method implementations. In other words, these are just kind of blank methods that exist for the sole purpose of complying with the MouseListener interface. And I remember when we talked about interface, I said there were times where you would do something like this, and usually in event programming, you do this. Because basically what does it mean is, well, sure, anytime that JLabel has a mouse pressed or released on it, these events will get called, but nothing will happen because I don't want anything to happen. So, even though there's no implementation and it looks like I'm cheating just to meet the interface of MouseListener, this is acceptable because I don't want anything to happen. So which ones do I want to happen? All I need to do is implement the bodies of the methods for those components which I want interacted with. So what I want is when you move your mouse over the JLabel, it changes the text to "you hovered over me." And when you move the mouse away, it says "hello class." Notice, by the way, what am I setting the text of? I'm setting it to the top variable. In other words, the object referenced by the top variable. Well, guess what? This is its own class. How come this class can access this variable? Well, remember all the way up at the top, I actually went ahead and I declared JLabel top and JLabel bottom as instance variables of the GUI sample1 class. And because my private class, myMouseListener, is a member of that GUI sample1 class, then it has access to those variables as well. So the reason why I declared these as instance variables is so that my MouseListener class would have access to those variables. Because, by the way, these are defined interfaces. The JVM expects these to be implemented as they are, and this is an instance where the contract or the defined way that the JVM interacts with your computer and then turns around and interacts with your program is helpful to you as a programmer. What's basically happening is the JVM is listening for events. It looks to see if any callbacks are registered with a specific GUI component when it's clicked on or moused over or whatever, and if it is, it basically goes ahead and executes the appropriate method within that given class. And in this case, again, I'm implementing MouseListener, so it knows that if you click, call mouse clicked. If you exit, call mouse exited. It passes in a mouse event, which we can actually do some stuff with, but in this case, I'm not. So notice I had a myMouseListener object up top, and I also had a myMouseListener2 object. So I actually went ahead and implemented two private classes. Both of them implement MouseListener. This is kind of a verbose and not the best way to work with multiple objects. In fact, there are ways that we can look at the event and determine what was the item that was actually clicked on, but I wanted to kind of make a point that you could have multiple private classes within another public class. And again, in this case, the only thing I'm concerned about with myMouseListener2 is what happens when the mouse is clicked. So basically what I'm saying is at that point, set the text to woot, and it changes it. And notice I have no way to set the text back to what it was. So I'm interacting with the bot reference because, again, that was declared as an instance variable of GUI sample1. I'm calling the setText method to change that to woot. So I think we're still running here. Notice there's what's happening from the first item that I demonstrated, and now this is already changed to woot because I clicked on it. So that's the basics of event listeners. You're basically going to implement a class that has the given functionality that you want. And after you have that class defined, all you're going to do is register an instance of that class with the GUI component that you want to have trigger those specific events. Let's take a quick look at some way you may see action listeners implemented in code as you explore the web and read through the book. And the concept that we want to talk about is called an anonymous inner class. So this is the code that we looked at previously, and if I run it, what you'll notice is that this is simply the programming code that has the Tux Penguin in it with the yellow background. The only difference is now I've gone ahead and I've added a button. Notice also, by the way, that the button takes on the default button look and feel of the Macintosh OS. It would be the same thing on a Windows OS. There are ways to override that, but I will leave that as an exercise up to you if you're looking to style your Java programs in a specific fashion. To be honest, I would just let the OS do its thing, but I know not everybody agrees with that. So where did I get this button from? Well, first things first, I want to go back up to the top of my class and show you that I've imported the java.auth.event package. And as I scroll down, I've actually gone ahead and I have implemented a few things. First off, I've implemented a J button. And I've called that J button button, and I have added the text to that button, press me. One other thing I had to do, and you'll see this if you play around with this code, is I also had to make my greeting, in other words, my label, final. And it just has to do with the concept we're going to talk of next. And this isn't always the case. In other words, if I would have declared greeting as a global variable outside of the class, actually in this case it would still be a problem because I'm doing everything inside my main method. But right now, if you see that final keyword and you're like, wow, why did he do that? Why is that there? It's basically just there to make this example work. So what do I have again? Just to repeat myself, I have a button. I've made my JLabel called greeting final so that this example will work. And here's where things start to look a little bit weird. I want it so that when you click on my button, it changes the text of my greeting to say test. And again, it's something we just saw me do. So if I pull this down in the window and I hit press me, notice it changes that text to the word test. So how does that happen? Well, first thing I need to do is I need to tie an event to my button. And because buttons are really meant to be pressed, in this case, I'm going to simply tie an action listener to that button. Why? Because the only real action that can be taken on a button is, hey, that button was pressed. So this is going to look a little bit weird, and I'm going to start to break down where this code is a little bit unique. I'm actually defining a class inside of the parameter list of this method. So here is the beginning of my parameter list for the addActionListener method call. Here's the end of the parameter list for my addActionListener method call, and the semicolon that normally ends the single line of code. What I've done differently is inside of the method parameter, I've actually gone ahead and defined what's called an anonymous class. I'm calling new to create an instance of the action listener class. So in other words, this is the constructor for the action listener class. And what I'm doing between these curly brackets is I'm actually going ahead and defining that given instance of the action listener class. And I'm saying action listener class, but I'm really working with the action listener interface. So what I'm doing here is I'm actually going ahead and meeting the demands of that interface's contract directly in code. Why? Well, why can I do this? Because again, the action of pressing that button is tightly coupled to that button. Like, the only time I want to set the text of this label to test is when I push this button. So I don't need a highly reusable object here. And in fact, this is such a simple little thing that I don't mind even just defining this in line. So I declare public void. I declare the action perform method because that's required by the interface. It accepts an action event that will be known as event inside the method, and it simply goes out to my greeting JLabel and sets its text to test. Now again, why is this declared final? Since this is an anonymous inner class, okay, to basically make the compiler happy, I have to declare this final because essentially what needs to happen here is that the anonymous inner class needs some reassurances that this object is not going to change, okay, after this has all been set up. So it makes sense to set this to final so that this is basically a constant, and now the anonymous inner class. Why is it called anonymous? Well, notice, what's the name of the class? There isn't one, right? Because I just defined it in line. Right? I'm just simply meeting the needs of the contract of the interface, calling the constructor, and getting back an object reference. So what's cool is I've defined the class for my object, called the constructor for my object, and been returned a reference to my object, and then passed that reference directly into the addActionListener method, all without having to write a separate file, all in line with my code, and all without having to worry about again, having multiple files. So it's very just convenient. I probably had a third idea there. I just forget what it was. But anyway, the idea being here is that I can do this. Now, when would you want to do this? Let's be realistic. It works really well for these little types of action listener events, but I would not want to do this in a larger program because it would just get to be a little bit cumbersome. And if you have, and again, in these little programs like we write, where you have one button, two buttons that do one or two little discrete things like calculate, converts Celsius to Fahrenheit or something, this is an appropriate approach. For larger programs such as JGrasp even, where you have all of these buttons, you have all of these things that can be interacted with, I'm not so sure that this is a great approach to take. But I wanted to show it to you because you'll see it in examples, and it's called, the process itself is, the definition is an anonymous inner class, and that's the syntax for it. It's possible to have one event processing object handle events from multiple inputs, such as buttons. So let's take a look at that in the code in front of us. Again, I've imported the java.auth.event class, so I can have access to, in this case, the action listener interface, so I can build an action listener object. One thing that's going to be new, this is actually the same program we looked at before that has the gray background and the Firefox mascot. And you'll notice the only difference at this point is that I now have 3 buttons across the top of the application. Notice that the mouse overs still work, and then I can still click on this label and still have the text change. But now I want to be able to process some events for these buttons so that as I press them, they indicate down here which button was actually pressed. So how am I doing that? How am I handling it? The reason why I chose to demonstrate this example or this concept in this example is because previously in this example we had created 2 separate mouse listener classes privately inside of this class to process our mouse events. What I'm going to do now is use a single action listener event to process the button presses. So as we scroll down, you'll notice that, again, by the way, I've declared the JButtons as instance variables to the GUI sample1 class so that they're globally accessible within this class. I've gone ahead and instantiated those JButtons to have the labels lowercase a, b, and c. Next thing I've done is I've gone ahead and I've attached action listeners to those buttons. And notice that each one of these action listeners is processed by an instance of the button processor class. Okay, I could have actually used the same instance for each of those, but I decided to just create 3 separate instances. Now if I scroll down, you'll notice that I add those buttons to my panel, and that's the reason why they were displayed. And if we keep scrolling though, we eventually get into my button processor, I can't even say that word, but my button processor class, which is an implementation of the interface action listener. And notice there's only a single method, action performed, that accepts input as event. And by the way, if you look at most of these listeners, they all accept as parameters a single object of type, in this case mouse event, and they're usually named event. And in this case it accepts a single parameter of the data type action event, and in this case it's called event. So all I need to do when I'm looking at having one method process input for multiple buttons is to go ahead and take a look at the source of the event. So in other words, I'm grabbing the current instance of the event object that's passed into the action perform method. I'm calling the getSource method on that object, and what that's going to do is return the source, or in other words, in this case, the object reference, in other words, the memory address of the event that caused the, the memory address of the item, or in this case, the button that caused the event. So just to clarify, getSource is a method that when called on the event object returns the memory address of the GUI component that triggered the event, in this case the button. So all I do is say, hey, is the address of this source equal to the address of my object stored in the variable A? In other words, back up here when I instantiated these JButton objects, I say, look, is the memory address of that JButton object the same as the memory address of the item in my application that triggered this event? If it is, then I know I pressed A. And again, I just look at the memory address of the JButton stored in the B variable, and I know that I can compare that memory address to the source of the event, and the same thing for C. So I can look at the source of the event, and I can respond appropriately. It's fairly straightforward. It's a very basic approach, and especially with buttons, if you have lots of them, it's a really nice compact way to avoid having a ton of different classes, which, is, in this case, a little bit of an if-else-if statement is much better than having multiple button processing classes. So again, and what's really cool too is notice now that when I click on this to change the button, or this display to Woot, because I clicked on this JLabel, now I have a way to get back to a different set of text via these buttons.